This is lesson 13.2, theoretical probability of compound events. Like I mentioned in 13.1, life is complicated and probability can have complicated parts about it too. So we're just going to get a little bit more complex, and that's thinking about compound events. And that's just two or more events that can happen. There are different types of compound events, but we're just going to focus on something called independent events. And that just means that the first event doesn't affect any other events. And let me break that down for you in right now. So if I had a cookie jar full of all different kinds of cookies, like chocolate chip and peanut butter, sugar cookies, ginger snaps, and I wanted to think about like reaching down into that cookie jar and pulling out a chocolate chip cookie. Well, I could find the probability of me pulling out a chocolate chip cookie. And if I put that chocolate chip cookie back and did that again and pulled out another cookie, I could find the probability of picking out a peanut butter cookie. And that's what we're thinking about independent events. The first event doesn't affect any other events. Well, this is a situation that would be affected. If I reached down into that jar and I pulled out a delicious, delicious chocolate chip cookie and then I ate that cookie, yum. That cookie is gone. It is no longer able to be counted in the jar. And so I could not pull out that same cookie again. There'd be less cookies in the jar and there'd be less chocolate chip cookies in the jar. So the first event, me pulling that chocolate chip cookie and then eating it, would affect all the other events, all the other times of me pulling that cookie out of the jar and eating them, because I'm never going to be able to get that initial chocolate chip cookie back because it's in my belly. Okay, so here are some examples of independent events. And we're going to roll a 6-sided die one time. And after that, we're going to randomly pull a scrap from a bag of scraps. It has 4 green scraps, 4 blue scraps, and 3 yellow scraps. What's the probability of rolling a number less than 5 and then drawing a green scrap? You can see that there's 2 things going on. We are rolling a dice and we're also pulling the scraps out of the scrap jar. So I'm going to kind of treat it as 2 separate things. I'm going to find the probability of rolling a number less than 5. Well, that's 1, 2, 3, 4 options are less than 5. Out of 6 options total on my dice. And then also this scrap situation, I want to know the probability of a green scrap. And so I know the bag has 4 green scraps. And if I count 4, 8, 9, 10, 11, 11 total scraps in the bag. So to find the chance of me rolling a number less than 5 and also pulling a green scrap out, all I have to do is find each separate probability and then times them together. So on my calculator, 4 6 times 4 11th, which is 8 over 33. So the chance of me rolling a number less than 5 and also a green scrap, 8 out of 33. Let's look at some more examples. So a bag has 4 orange rocks, 2 green rocks, 2 white rocks, 3 yellow rocks. You randomly pull a rock from the bag, put it back, and then pull out another one. So this put it back situation, excuse me, means that the rock's going to be back in there for me to pull it out again. It's not like me eating those cookies. So I want to find the probability of getting an orange and then an orange. So probability of orange. And then probability of orange. I want that to happen twice. Okay, so orange, 4 orange rocks. And there are 11 rocks total when I add up all of the colors. Well, that was easy enough. It's going to be the same thing for the second thing. And again, in order to find the chance of both things happening, I'm going to just multiply the probabilities together, which is 16 over 121. Okay, so you spin a spinner that is equally divided into 9 parts, and then you spin it again 3 are red, 1 pink, 2 green, 3 yellow. What's the probability of the spinner stopping at a red section on the first spin and a pink on the second? So probability of red, probability of pink. So red, well, that's 3 out of the 9. And pink is 1 out of the 9. And to find the chance of both of those happening, like pink then red, I'm going to just find the product. I'm going to times the two fractions together, which is 1 out of 27. All right, there's 2 more little problems here. You randomly draw twice from this deck of cards. Excuse me, here it is. What's the probability of drawing a C and then a C? So again, in this problem, we want the same thing to happen twice, and I'm putting those cards back, so that's good. So everything is going to be good. 1, 2, 3 C's out of 7 total cards. So this is going to be 3 out of 7, up 7, which is 9 out of 49. Okay, last problem. Jake stood in line to pick up a souvenir postcard at the museum. All the postcards were either blue, white, or green, with a picture of a fish, insect, or bird. There was an equal number of each type of postcard. What is the probability that Jacob was randomly handed a green postcard with a fish on it? So I want it to be green, and I want a fish. So I'm going to look at the probability of being green. So that's blue, white, or green. So green is 1 of 3 choices. And then fish, insect, or bird. Oh, that's also 1 of 3 choices. So to find the chance of both things happening, 1/3 times 1/3, 1/9.